Hello students and welcome to yet another video on foundation course for business statistics. In this video we are going to go through correlation coefficient. Let's get introduced to what correlation is. See, so far we have actually seen in which only one variable was involved, right? So we calculated what is central tendency for a particular field, right? Now that could be a group data or ungrouped data. We also calculated measure of dispersion, but for a single variable, right? For a single field, right? For a single column to be precise. Okay. Uh, in correlation, now we are going to study the variation that is involving two or more variables, right? So it could be rainfall and crop, rainfall in and yield of crops in probably tons. We would see height and weight, height in centimeters and weight in kgs. Okay, so what's correlation? So correlation is when there is a variation in one variable, uh, how is the variation uh, on the other variable, right? So that is what we are going to see. If one variable values in one variable increases, then what happens to the values in another variable? Do they increase? Do they decrease? Or there is no impact at all, right? Correlation analysis measures the degree of relationship between these variables, right? So we actually calculate what is the degree of relationship. Okay, if correlation is extremely high, okay, uh, if one variable increases and other also increases, we say two variables are related to each other and correlation is extremely high, and we calculate the degree of this correlation. Okay, most important thing, correlation implies covariation, but it necessarily doesn't imply a causation. So what does it mean? Let me give you an example, right? So suppose uh, I say that sales of ice cream increases and so does the number of drowning incidences. Now it's very weird because these are two different uh, variables altogether, not related to each other. How can sale of ice cream increase and so does the number of drowning incidences? So there is no direct relationship between these two variables. But remember, there can be, or understand, there can be one relationship, and that is when heat increases, sale of ice cream increases. And when heat increases, people go to swim. And that is where number of drowning incidences increases. Okay, so there may not be a direct cause between these two variables, but there may be a third indirect third variable because of which the cause effect appears, right? So this is what the last statement really means. So let's go through what are different types of correlations. So first, most important, positive correlation. What does positive correlation means? When both variables move in the same direction. For example, when rainfall increases, so does the crop yield increase. So rainfall also increases and crop yield also increase. So these two variables are correlated to each other, and the correlation is positive because when one increases, other also increase. Next is negative correlation. In this case, when the one variable increase, the other goes in the opposite direction. So for example, when the price of a product increase, the demand decreases, right? If the price of the product decreases, demand increases, right? So there is third type of correlation. The correlation can be linear correlation. Constant linear correlation is constant rate of change between the variables. So uh, you can easily arrive at a constant, or you can easily arrive at the equation, because there is a constant rate of change. So if I change the value of x, which is one variable, okay, then the value of y changes in a constant rate, and the equation could be of type y is equal to mx plus c. So linear correlation actually depicts a line, right? So here your x variable and here is your y variable, and all the linear equations can be easily depicted in terms of line. Okay, non-linear correlation, the change is not constant, so it forms a curve and not a straight line. Another type of correlation is simple correlation. In simple correlation, we are actually responsible, or we are actually expected to arrive at relationship between two variables only. Whereas in multiple correlation, uh, relationship is among more than two variables, right? Whereas in partial correlation, you study two variables, keeping other variables constant. Yeah. In this series of videos, we are basically going to concentrate on simple correlation. Okay, let's move on. So how do we measure correlation? Correlation is measured using Carl Pearson's coefficient of correlation. And how is that calculated? Typically, correlation coefficient is depicted by R, and it is calculated as covariance of x and y divided by standard deviation of x multiplied by standard deviation of y. So this is basically a formula to calculate R, right? And here we are calculating the relationship between, we are measuring the relationship between two variables. One is x and other is y. Okay. Now, how do we calculate the covariance? Because here we have seen a covariance. So, covariance between x and y is, okay, you calculate the mean of x plus, which is x bar, right? Then you calculate the mean of y, which is y bar, and then take a product of x minus x bar. Take every observation of x and reduce it from x bar. Similarly, take every observation of y and reduce it from, or subtract it from y bar, and take the product of this, right? X minus x bar into y minus y bar. Take a summation of that and divide it by n. So this gives me basically what the covariance is. Okay, so once I find the covariance between x and y, then all that I have to do is, right, that becomes my numerator. So covariance xy becomes my numerator, and I divide it by standard deviation of x and standard deviation of y. We have already seen in previous videos how to calculate standard deviation of a variable, right? Let's move on. In fact, this formula will be well understood when I'm going to take numerical examples in my next video. Till then, let's further understand uh, what uh, what are the properties of correlation of coefficient, and how do we interpret uh, whatever values we get from for R. What should be the interpretation? Okay, always remember that R lies between -1 and +1. So -1 is less than or equal to R is less than or equal to 1. I have seen many a time students doing a mistake calculating correlation coefficient, and their final answer comes more than one, or probably less than -1. Uh, but the moment you come or arrive at that situation, you should immediately understand that you have done some mistake in calculation, because R is always between -1 and +1, right? So R is independent of change in origin and scale. We have already seen when we are seeing some observations that were noted on standard deviation. What do we mean by change in origin? So basically, if we constantly increase by the observations in X or in Y, okay, with a constant value, right, then R doesn't change. Correlation of coefficient will continue to remain same. And same is true with scale. If we multiply all the observations in X or all the observations in Y by a constant value, then R doesn't change. Okay. If you get a value of R as 0, then two variables are independent variables. They are not correlated to each other. How do we interpret? If R is equal to +1, then it indicates that it is a perfect positive correlation. And if R is -1, then it indicates that it's a perfect negative correlation. So when we say positive correlation, if X increases, Y also increases, and if R is equal to +1, then it's a perfect positive correlation. If R is equal to -1, then it's a perfect negative correlation. If X increases, Y decreases, right? So typically, if R has values close to +1, see anything between 0.7 to 1, right? We can say we have a high degree of correlation, or if high degree of positive correlation. And if we have value of R as -0.7 to -1, we will have high degree of negative correlation. And if R is equal to 0, then there is no correlation. There are two more measurements. One is coefficient of determination. Now, coefficient of determination is very easy to calculate. Once you get R, all that you have to do is do R square. And once you do R square, it gives you the percentage, right? So you just have to multiply this by 100, and it actually gives you the percentage variation of one variable that is associated with other variable. Okay, so that's coefficient of determination. And then another one more measure is probable error of correlation coefficient. Now here you calculate probable error for R, that is PE. R is calculated by you multiply 0.6745. Okay, you multiply it by 1 minus R square divided by root n, where n are the number of observations, right? R square is nothing but your coefficient of determination. So you minus it from 1, you reduce it from 1, and multiply it by 0.6745, right? So if the value of R is less than PE, then the value of R is not significant. So basically, probable error of correlation coefficient is used to measure the reliability of the observed value of R. So I know in this video we have seen three formulas. We have seen properties and how to interpret correlation of coefficient. Uh, this theory will be well digested when you look at some numericals pertaining to correlation of coefficient in next video. Till then, thank you so much.